Okay. Number 25. Does anybody know the vocab word for this picture? Starts with a V. Ends with an article. Vertical. Yeah, these are called vertical angles. I like to think of vertical angles as a reflection. And vertical angles are equal. So if this side is 87, then that side also has to be 87. So B is 87. Okay, last one. Does anybody know the vocab word for this picture? If not, I can, oh, Tice, yes, honey? Yes, beautiful. I like to remember alternate interior by thinking about them being on alternate sides of the transversal, but in the interior of the parallels. So that's what gives me alternate interior. Okay, alternate interior angles are also equal. So if this is 50, then that would also be 50. So B is 50. Okay. So this is your warning right now that your warm-up should all be done at this point. Check your packet and make sure that all of the warm-ups from 1 to 26 are done. This is an assignment that I stamped. I'm not going to stamp it this minute. So just so you know, this is your warning. Make sure that all of your warm-ups 1 through 26 are done. And if you don't have them all done, you need to do those. Okay, any questions about that? Okay. Okay, today we're going to work on exponents again. We're going to do something spicy. It's 0 and negative exponents. I don't know that this is as hard as domain and range. I think domain and range might still be harder than this, but this is definitely not easy. We're going to do problems 73 through 78. They're all in your notebook. So you're done with your packet for the moment. And here is the homework. The homework is 81 to 85, and there's my joke. Homework cat does not share answers. Homework cat is very serious about not letting you cheat off the paper. Do you see the homework cat? And its seriousness. Homework cat is actually super adorable. Yep, homework is 81 to 85, guys. That's what we're doing right now. Perfect.
Okay, thank you. Forgot to put my phone, so I'm not going to stand to the.
Yeah.
For sure.
Appreciate you. This is not. That's not. Eleven, 14. 11, 14, what is that? Okay, guys, so we're actually going to do this one a little differently than we did last week. And you're going to be happy about that because we're going to do it with the shortcuts for exponents. So what does that mean? That means we're not going to write it all out. There actually are some instances where I think it's better to write it out, and that is only for a little bit of f, but all of the rest of these, we're just going to answer the question and then we're going to say what we did. So in this problem, I want you to think I have 7 x's and 4 more x's. So that gives me a total of 11 x's. Even though this is multiplication, we are adding the exponents. So for multiplication problem, you actually add the exponents. Okay, for B, this is an exponent to an exponent. It's an exponent to a power. This is x to the 9. When you have an exponent to an exponent, you multiply exponents. Okay, next one. This is a division problem. Division means that you look for giant ones and there would be 2 of them to cross out. So that would give me m to the 12th. And I subtract the exponents. Okay, now this one right here. Which one is it more like, A, B, or C? B, right. Okay, so this one is a multiply exponent. So x to the 8, y to the 8. Okay, E, which one is this more like, A, B, or C? C. So we're gonna subtract 5 minus 2 is 3. 11 minus 3 is 8. Okay, and then this last one I threw in a little bit. This is just like C and E. The first thing I'm going to do is subtract the exponents. So I have 2x to the 10 over 8. Okay, however, pausing there, first of all, do you guys see where I got the x to the 10 from? Okay, now I have to blast myself back to 4th grade. And I have to remember that this is just a fraction that you reduce. So 2 over 8 reduces to 1/4, but we don't usually write the 1 in front of a variable. We just leave that off. Okay. We cannot move on from this until you guys are kind of okay with number 73. Any questions about number 73 before we move on? It's a super important topic. Super, duper. Okay, now the next problem, I'm going to start working with negative exponents. None of these were negative. So this is stuff that, you know, should be kind of not easy, but easy-ish. Now we're going to get into stuff that is not easy. I got a lot to set up in this problem. Just kidding. Okay, so number 74. This is going to be Mrs. Talbot's famous demo for negative exponents. Here we go. I'm going to start with something that everybody's familiar with. This is just a regular number to an exponent. And I want you guys to all think about it in expanded form. Okay, do not, at this moment, tune me out because this is easy. Do not tune me out because this is easy. This is about to not get easy in a moment. I'm trying to do that thing. You know, like instead of jumping into a pool, you like walk in like slowly. That's what we're doing right now. Okay, so is everybody okay with this statement? Okay, so now what we're going to do is we're going to go down a power. We're going to go to 3 to the 3rd. (27), beautiful. Okay. What we're doing, this is one of the skills of a mathematician. We are finding a pattern. We're looking for a pattern as we continue. 3 squared equals 3 times 3, which is 9. Okay, now stop here. What is happening to these numbers? What am I doing to them each time? Right, so I am dividing by 3. I want you to think 81 divided by 3 is 27. 27 divided by 3 is 9. And it makes sense because I'm removing a times 3 here. Okay, this should all be good so far. You guys are like, okay, where is this going? Does the pattern continue there just fine? We're good? Okay, now this is where, you know, like when you're just getting into super cold water and this is like the moment when you get to this point where you're going to get used to it or not, like right here, this is where you're at. Okay. Mm-hmm. It's going to feel really weird, but 0 power is 1. Anything to the 0 power is 1. 4 to the 0, 2 to the 0, negative 10 to the 0, x to the 0, Mrs. Talbot to the 0, Dylan to the 0, smiley face to the 0, 1, always. If you could just Remember, it's something divided by itself. So, okay, now we're going to go a step further. Ah, so 1/3. Why? Because it's the previous thing divided by 3. 1 divided by 3 is 1/3. One-third divided by 3 is 1/9. Okay, we're going to write ourselves a note over here. So, and we're going to do this one. 3 to the negative 5. Jumping ahead. Okay, so let's go look here. All right, so 3 to the negative 5 is going to be 1 divided by 3 to the 5. I don't care what 3 to the 5 is. I think it's 243, but this is the statement that you need to listen.
What is it like? We have appliances. Like,
Excellent question, because a lot of times when we take a negative exponent, it will be have a negative, the negative times a negative, which would be a positive, but not in this case. Okay. And this, I have a question for you, actually. Do you know what the word reciprocal is? Okay, so do you guys know what the word reciprocal is? Do you know the fun, silly way that we learn to remember the word reciprocal? Did you guys not learn?
No.
Reciprocal. Okay, reciprocal means you flip a fraction over. A reciprocal is a fraction flipped. So then you say reciprocal, change the word flip to flip, reciprocal. Okay, what I mean by that is 3 to the 1/3 is the reciprocal, the flip. Three to the negative 5 is the flip. Okay, so all we're going to do is flip them, which is going to be very easy. Maybe. You guys can write down 75 and 76 right now. 76 is luckily very short. Okay, so now what we're going to do in 75 and 76 is we're going to combine our knowledge from 73 and 74. We're going to put problem number 73 and problem number 74 together in a second, because I didn't really give people enough time to write it down, because I'm just so excited about negative exponents over here. I was talking to my husband on the way to work this morning. He's like, what are you teaching today? I was like, negative exponents. He's like, what are those? I'm like, well, and then I explained it to him. He was like, I'm an auto mechanic. I don't need to do that. And I was like, but he does have a lot of really super cool graphs and stuff that he shows me all the time. Anyway, okay. All right. Do you guys see that this problem is division? Okay. Can you like look at that and be like, that's dividing? Okay. Now, when we divide, we subtract the exponents. What's 4 minus 5?
-1.
Beautiful. Okay, now this is the moment of truth. We can't leave it like this. You can't leave final answers with negative exponents. Yes, honey. Yep. Okay, so what you do is reciprocal. Reciprocal means move it to the bottom, flip it. And then do we ever really write x to the 1? No. Final answer. Okay, if you didn't understand that, that's okay. We're going to get back on the ride and go again. What's 2 minus 4? Beautiful. So, oh, Mrs. Talbot, it's negative. Reciprocal. We getting it? A little bit? Okay. C. 7 minus 10. -3. Reciprocal. Okay, now 76. This one's special. 4 minus 4. What's x to the 0? 1. And I love this problem. I really want to focus on this problem for just a second. Do you guys see, does anybody else see why I love it? Can you predict why this is a math teacher's dream problem here? Yes. That's like my son's answer when I ask him what he wants for dinner and he says food. And that happens often because he thinks he's hilarious. He is kind of hilarious. Okay, okay. Why is this a math teacher's dream problem? What would happen if I wrote this out? No. Okay. Okay, hold on. Can you guys imagine 4 x's on the top and 4 x's on the bottom? And then what would I do? Yes. Yeah, and I would make 4 giant ones. And what's 1 times 1 times 1 times 1? 1. Yeah. Yes, I made up my own because I'm better than CPM sometimes. That's what happens when you get 20 years in. You're like, you know what? These are not good. Mine are better. Okay. Any questions about these? Okay. Now we're going to do some serious advice, and then we're going to quickly summarize what we learned today. And then you have your scavenger hunt time that you need to finish that or fix it, because some of you need to fix it. Maybe. Not speaking of anyone in particular here or anything. Notice the amount of room I left. Just throw that out there. Also, if you like to use different colors in your notes, I'm going to use red for part of this, just so you know. Okay. There's my opinion, a very easy way to do this and a hard way to do this. So I'm going to suggest a method for you. The first thing you want to do is fix the negative exponents. So looking at the problem, do you see any negative exponents? Okay, and what you're going to do is circle that or indicate it, underline it somehow. I need to do the reciprocal of this. So I'm going to move it to the other side. Reciprocal means move it to the other side. Okay, are you with me so far? I took a negative exponent, anything that had a negative exponent, and I moved it to the other side to get the reciprocal and make it a positive exponent. Okay, now I have 18 times x times y over 30 times x times x times x times x times x. Okay, do you see any giant ones? Yes, here and here. Okay, so what is left on the top? 18y over 30x cubed. And then I transport myself to fourth grade. What goes into 18 and 30? 6. Okay, so here are my steps. Fix negative exponents. I really right now. Fix the negative exponents, write it out, and reduce. Fix the negative exponents, write it out, and reduce. For B, do you see any negative exponents? Okay. One here, one here. Those are going to go to the bottom and become positives. So both of those two are going to the bottom. Now what's left on the top then? Negative 5y, negative 2x cubed. Okay, now I'm going to write it out. Negative 5 times y times negative 2 times x times x times x over x times y times y. Okay, step 1, fix the negative exponents. Step 2, write it out. Step 3, reduce. Can you see anything I can reduce? Any giant ones? 2 x's And one set of Ys, yep. Okay, so what's left on the top? Yep, positive 10x. Y on the bottom. I did not want to put that there. I did not want to put that there. I didn't want to put that there. Okay. Last problem till our very short notes. That's not all of it, by the way. Don't get excited. Okay. Do you see any negative exponents? Yes. Okay, so I'm going to circle that. And I'm going to move it up to the top. Okay, step 1, fix any negative exponents. Step 2, write it out. Step 3, reduce. What can I reduce? Beautiful. To what? Oh, it divides by 15. So 1 and 3. Gorgeous job. Okay. What else can I reduce? Landon? How many? Okay. So moment of truth. What's left on the top? Yep. Okay. And you can write 1x divided by 3 if you want to. I will not mark that wrong. I'm just going to put x over 3. Okay. Last problem. You're just going to write this. Okay. For the rest of the period, you're either working on, hold on. For the rest of the period, you're either working on problems 81 to 85, which is tonight's homework, or you're working on the scavenger hunt and fixing it. When you finish your scavenger hunt, please come over for a stamp. Yes, you may go to the bathroom.